Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the directory traversal module titled File Path Traversal Simple Case. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down again, select directory traversal, and then go down one last time to lab number 1 titled File Path Traversal Simple Case. Alright, let's get started. This lab contains a file path traversal vulnerability in the display of product images. To solve the lab, retrieve the contents of the etc passwd file. Alright, so the target goal over here is to exploit the file path traversal vulnerability and retrieve the contents of this file. Okay, let's get started. Now notice over here, this is the built-in browser in Burp, and so all my requests are already getting intercepted in Burp. Alright, so while the application is loading, notice over here it loads a bunch of images, and these images are likely taken from some kind of folder on the backend server that is hosting this application. And so this is your first indication that you should definitely be testing for path traversal vulnerabilities or local file inclusion vulnerabilities or even remote file inclusion vulnerabilities. And so the first thing that we're going to test for is path traversal. So let's send this to repeater. And then I'm going to move this right over here and hit send. Now over here, the response is a 200 OK response, and it displays the content of the image that is in this JPEG file, so the 65.jpg file. Now, if this is vulnerable to path traversal, we should be able to view the contents of other files on the server. However, something to keep in mind is that we're only able to view contents of files that are readable by the privileges that this application is running as. And usually applications are not run with root privileges because that would be really bad. That means we could read any file on the system, including sensitive files that could have hashed passwords. However, in most cases, it's only run with some kind of web daemon user that has very limited privileges. And so to test for path traversal, what we're going to do is we're going to try and access a world readable file. So it's accessible by anyone that has access to the server. And that file is going to be the passwd file. So the first thing that we're going to do is we're going to see if it accepts absolute paths. So we'll say etc and then passwd, hit send. And it says no such file. Now, if it doesn't accept absolute paths, it starts with the folder that the JPEG image was in. That means we need to try and get out of the folder. And so what we're going to do is we're going to add ... / to try and get out of the directory that we're in. And I'll explain that in a bit. Let's put 4 just in case. Okay, so the reason I added the ... is because chances are the JPEG image is retrieved from a folder that is similar to this one. So var /images, and then we had the 65.jpg image. Now, whenever I enter a file over here, so let's say the passwd file, it'll look for the passwd file in this directory. So var images and then etc/passwd, which it does not exist in this directory. This exists in the root directory. So what we're going to do is instead of doing that, we're going to add this comment over here. So what that means is get out of the current directory, which is the images directory, and then add another one which says go to the parent directory, which is the directory, and then we're going to add another one. And so it's going to say get out of the var directory. And so it ends up with just the root directory and then the etc folder and then the passwd file. And so essentially what you could do is instead of just assuming that it's 3 directories up, you could add the ... / characters as many times as you want to ensure that you actually get to the root directory. So if we hit send right over here, you could see it solves the exercise. It says, congratulations, you solved the exercise, and it dumps the content of the etc passwd file. So again, I mentioned if you're not sure if it's 3 directories up, what you could do is just add a whole lot of other move up to the parent directory, and it should still work, because eventually it'll only get to the root directory and then it'll look for this specific path. All right, so we successfully completed the exercise by manually exploiting the path traversal vulnerability. Now let's script it in Python. Okay, so this should be relatively simple because we don't need to authenticate to the application. This is essentially an unauthenticated vulnerability. And so the first thing that we're going to do is import the sys library, and then the requests library, the URL lib3 library, and disable insecure request warnings. So URL lib3 dot disable warnings, URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy setting just like we usually do in all of our scripts, because we want all of the requests that are made by the script to get sent to the burp proxy, so that in case the script doesn't work properly, we could debug our script and see the request that it's making in burp and figure out what's going on. So send all HTTP traffic to where burp is running, which is HTTP 127.0.0.1 and port 8080, and also send all HTTPS traffic where burp is running, which is again HTTP 127.0.0.1 and port 8080. And then we're going to create our main method. So if name is equal to main, then call the main method, and we'll define the main method right over here. Okay, so for the main method, we're taking in a command line argument. So we're going to say sys.argv, and if we're going to say if it's not equal to 2, so if it's not equal to 2 command line arguments, that means the program was run incorrectly. So we're going to print the usage and the example instructions. So usage instructions, the name of the program, which is taken from the command line, and then the URL. And then we're also going to print the example instructions. So example, and again, the name of the program, and an example URL. So let's say www.example.com. And again, we take the name of the program from the command line arguments. And we exit the program. All right, so we'll enter this if clause if the user does not run the program correctly. If the user does run the program correctly, what we're going to do is create a variable called URL and set it to the second command line argument, so sys.argv1, and then we're going to print a statement saying that we're exploiting the directory traversal vulnerability. And to do that, we're going to call a function that we're going to create. So directory traversal exploit, and it's going to take in the URL parameter that we just passed in the command line. Okay, this looks good. Now let's define our function. So def directory traversal exploit, and again, it takes in the URL. The first thing that we're going to do is set the path that contains the vulnerability. And so we're going to call it image URL because it is the path that retrieves the image. And that's going to be the regular URL plus this path right over here. So let's copy that. And we could add our exploit right over here. So we're going to say dot dot slash dot dot slash dot dot and then slash dot dot slash, and then we're going to say etc passwd. Now this could be replaced with any file on the system that is world readable. And again, if the application is running with root privileges, which is against security standard, but if it is, then you could attempt to obtain the shadow file, which does contain hashed passwords. Okay, this looks good. And then the next thing to do is just perform our request, which we do using the requests library. We say .get because it is a get method right over here. And so it takes in the image URL that we just set. We're going to set verified to be equal to false because I don't want to verify TLS certificates, and proxies to be equal to proxies. And then I want a way to verify that my exploit worked. And so to do that, I'm going to look for this specific string over here. This will always be there in the response because the root user is always a user of the system. Okay, so I'm going to say if I see this specific string in the response of my request that I just made, then I'm going to print a statement saying the exploit was successful. And then I'm going to print another statement saying the following is the content of the etc passwd file, and I'll just dump the response so that it dumps this right over here, which is the content of the file. Now it'll enter this if clause if the exploit was successful. If it wasn't successful, then what we want to do is enter an else clause and print exploit failed. And then we want to exit the program because our exploit failed. All right, this looks good. Let's save it. So to recap, we've got our main method right over here. It takes in two command line arguments, the name of the program and the URL of the vulnerable application. And then it calls this function right over here. In this function, what it does is it essentially performs this request, which exploits the path traversal vulnerability and then dumps the content of the passwd file. Let's see if we have any mistakes in our script. So terminal, new terminal. And then we're going to say Python 3 directory traversal lab01 and the URL of the application, which might have timed out, and it did. So let's run it again. Let's copy that, put it in here, and remove the trailing slash, and then hit enter. And here we go. It says, congratulations, you solved the lab. If we look at the content of the response, you could see it says it's exploiting the directory traversal vulnerability, and then it was able to successfully exploit it, and then it dumps the content of the passwd file. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of path traversal vulnerabilities.